Hi guys, by adding other components to the negative feedback circuit, an op amp can be made to do a number of interesting things beside amplification. So in this video we are going to see an inverting amplifier. So we will be solving for the gain of this circuit of negative feedback. So because we have a negative feedback, we know that the output will attempt to make the difference between the inputs to be zero. So we know that V plus minus V minus will be equal to 0 because of the negative feedback. And since V plus is connected to ground, V minus will also be 0. So this expression means that V plus will be equals to V minus, and they will all be equal to 0 watt because V plus is connected to ground. To figure out the gain, which is given here, we must find current 1 and 2. So this one current here, current 1, and there's another current here, this current 2. So we must calculate for current 1 and 2, so we can come up with an expression containing V out in terms of V in. Therefore, using Ohm's law, we find E1 and E2 to be as so. E1 will be equal to the potential difference across the resistor 1 over R1. So it will be V in minus V minus over R1, and E2 will also be equal to the potential difference across R2 over R2. So E2 will be equal to V out, because V out here, minus V minus over R2. But since V minus is 0 volt, E1 will be equal to V in minus 0 over R1. Likewise, E2 will be equal to V out minus 0 over R2. Therefore, E1 is equal to V in R1 and V2 V out R2. Because an ideal op amp has infinite input impedance, no current will be drawn by its input terminals. Therefore, we can apply Kirchhoff's junction rule at this point to get, let me write here, to get E1 plus E2 equals 0 because no current will enter here. Therefore, E2 is equals minus E1. Now, by substituting the calculated values of E1 and E2 into the expression here, we get, so into this expression we get V out over R2 is equal to minus V in over R1 then we can derive V in from here, will be equals to minus R1 over R2 times V out. We just multiply both sides by R1 and then move the negative sign there. So now that we know V1, we can put it into the expression of the gain or the formula for the gain to calculate the gain. So we know the gain is V out here over V1. But here V1 is V in over V in. V in is minus R1 over R2 V out. So it will be times R2 over R1 times V out. We have to bring the negative sign here, remember. So V out will cancel out with V out. So we get the gain to be minus, because of this minus, R2 over R1. The negative sign tells us that the signal that enters the input, so the signal that enters the input will be inverted, that is shifted 180 degrees at the output. And also we can notice that if R1 and R2 are the same, then we get the gain to be -1. So in this case, in case of R1 equals R2, we get what is called unity gain inverter. So let me write it here. So write it here. If R1 equals R2, then the gain will be equals to -1, and this is called unity gain inverter. Instead, when using real op amps that have relatively high input bias currents, it may be necessary to place a resistor with a resistance equals to the power of these two values, power of R1 and R2, between the non-inverting input and ground to minimize voltage offset errors. So actually it will look something like this. Let me see if I can draw it small down here. So for a real resistor, to minimize the input offset current error for a real op amp, we need to put a resistor between the non-inverting terminal and ground of the value R1, the power of R1 and R2. Sorry, okay. So to minimize input bias current for a real op amp, it may be necessary to put a resistor between the non-inverting terminal and ground of the value, the power of R1 and R2. See you in the next video.